Yeah, in 2 minutes we'll start. Assalamu alaikum, dear students. In 2 minutes we'll start exactly at 3:50. We'll start the session. And we'll start now. Actually, in our channel, we'll be posting videos for 11th standard metric and 11th standard, 12th standard metric and 11th CBSE and 12th CBSE. But this live session is completely different. Live session, I'm just taking it for my school students' purpose. So there will be no continuity if you check the live session. If you see the other videos, it will be having the continuation. Now we'll get into the topic now of our live stream. Right. So we are going to see trigonometry today. Right. So trigonometry is nothing but it is a combination of two Greek words, trigonon and metry. Right. Trigonometry is a combination of from trigonon. They have skipped this word n, and metry they have taken it as it is. So from the Greek word trigonon and metry, trigonon means in Greek we call it as triangles. Trigonon means it is a Greek word, the meaning is triangles, and metry is nothing but measurement. And metry means nothing but measurement. So trigonometry is nothing but measurement of triangles, right? So in that especially measurement of triangles, but especially we'll be focusing more on right angle triangle. Why? Because if we study properties and characteristics, everything about the right angle triangle, we can easily study the other triangles. How? For example, let me take a equilateral triangle or any triangle like this. Now this is not a right angle triangle, but any triangle can be split it into two or three, right? Split it into two, right? If I draw a perpendicular line from any one vertex to the opposite side like this, now this ABC is not a right angle triangle, but I have split ABC as ABD is one triangle. It is a right angle triangle, and ADC is another triangle that is also a right angle triangle. So ABC is not a right angle triangle. Triangle ABC is not a right angle triangle, but I am writing ABC as a combination of two triangles where these two triangles are right angle triangles. So any triangle can be expressed as a combination of two right angle triangles. So if we study completely about the properties and characteristics of a right angle triangle, then it will be easy for us to study all the other triangles as well, right? So this exercise will be discussing about the properties and characteristics of a right angle triangle especially. Right, now getting into the topic, right angle triangle. If I take a right angle triangle, any triangle has three sides, but we have a special name for a right angle triangle. Let me draw a right angle triangle. Any triangle has three sides, but for right angle triangle, I'll take this longest side, we call it as hypotenuse. We call it as hypotenuse. And regarding the other two sides, if I'm considering this to be my angle, let me take A, B, C. For this angle C, let me take it as theta. For this angle C, which is the opposite side for this angle, this is the opposite side. So this is the opposite. This is the opposite side for this particular angle theta, and for this theta, which is the adjacent side, this is adjacent. This is the side adjacent to this angle theta, so we call it as adjacent side. Adjacent side. Now listen, when we have three objects, let me take it as like some A, B, or C, or if it is configured, instead of taking it as variables, let me take a star, let me take a circle, let me take a box. Now there are three objects, three chocolates, take it as three chocolates, right? In what are the possible, there are two students, if there are two students, one student take it as like a, take it, imagine that this is the house, ground floor and first floor, right? There is a small kid in this house and small kid in this house. In what are the way we can give these three chocolates to the kids? Either I can give star to the this to the first floor kid and this to the second floor kid. Yes. And what is the other option I can have? I can have it. Second option is star and box. Star, box. What is the third option? Star, circle and box. Now we can do it everything. This also in the reverse pattern. Round by star, box by star, and box by circle. You imagine that I'm giving this chocolates in six different ways. Here star to the first floor kid and round to the second floor, ground floor kid. Here star to the first floor kid and box to the ground floor kid. Round to the first floor kid and box to the ground floor. So if there are three objects, what are the possible? How many possible ways we can split like this? We can split in six different ways. Six different ways like this. We have no other option. Only these are the six possible cases, right? So same way, if I take it this ratio for these three with the help of these three sides, if I try to find the possible ratios, what are the possible ratios I can have it? I can either have opposite by hypotenuse, this by this. Second option, adjacent by hypotenuse, and the third option is opposite by adjacent. And what is the fourth option, fifth option? The reverse of it, hypotenuse by opposite, and hypotenuse, the reverse of this is hypotenuse by adjacent, and the reverse of it, adjacent by opposite. Right, now these are the six possible ways I can write. If I try to find the possible ratios with the help of these three sides, only these are the six options. Now actually we would have studied like sine theta is opposite by hypotenuse. Actually the correct procedure is opposite. We have, with the help of these three sides, I am forming six ratios. For these six ratios, I am giving the name to be, for this ratio I am giving the name to be sine. The full name is SINE. We'll write shortly as SIN. And for this, we are naming it as, like, there are six babies. I'm just naming the babies like Raj will name it, right? Rajesh, Ramu, like that. Like that, I'm just naming this ratio as sine. I'm naming this ratio as cos. I'm naming this ratio to be tan. I'm naming this ratio to be cosecant, and this ratio to be secant, and this ratio to be cot. Right? Now, actually the full name is sine, SINE. Here cosine, tangent, cosecant, secant, cotangent. And we will use the short name. Now, for all these six babies, who is the father? Which is the origin of it? With the help of this theta. Since this is my theta, for this theta, this is my opposite and this is my adjacent. If I change my theta to be this part, this angle A, then this will become opposite and this will become adjacent, right? So that opposite side and hypotenuse is the fixed one. The longest side, we call it as hypotenuse. Yes, but when it comes to opposite side and adjacent side, it depends upon the angle. If this is my angle, for this angle, this is opposite and this is adjacent. But if I take this to be my theta and A to be my theta, then this will be opposite and this will be adjacent. So for this ratio, for this diagram, I have taken this to be my theta. So theta is the origin for this to be my opposite and this to be my adjacent. So like for all these six kids, who is the father? The theta is the father. So every name, every student, we all have initials, right? So like that, initial of all the six kids, is theta, 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 theta. So we would have studied, like those who have studied trigonometry in earlier classes, we would have studied like this: sine theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent, right? But actual thing is for the ratio that we are getting, we are naming it as sine, cos, tan. It is not sine or sine theta is opposite by adjacent. Of course, both are same. But when we read it, when we understand it, we should understand in this way, right? We are getting 6 ratios with the help of this right angle triangle. For those 6 ratios, we are naming it as sine theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta, right? So this is how we are getting. These are the 6 trigonometric ratios. These are the 6 basic trigonometric ratios. Now, after studying about these 6 ratios, we'll have relations, equations, or identities with these 6 ratios. The basic identity that we must study is there are 3 basic identities. That is, first one is sine square theta plus cos square theta equal to 1, and the second one is secant square theta minus tan square theta equal to 1, and the third identity is cosecant square theta minus cot square theta equal to 1. Right. Now there are these are the 3 basic ratios, 3 basic identities. We have some more identities. First let me explain. I'll give you the proof of this alone. Similarly, you can see the proof of these two also. Right. First, let me prove this. What is sine theta actually? Sine theta is this. So what will be sine square theta? Let me up this. So what will be my sine square theta? This is my sine theta. What will be my sine square theta? Sine square theta will be opposite square. It is O square by H square. Opposite square by hypotenuse square. What will be the cos square theta? Cos square theta will be A square by H square. A square by H square. Right. Now, if I add these two, what I'll be getting? Sine square theta plus cos square theta equal to O square by H square plus A square by H square. Now denominator is the same, so H square O square plus A square. O square plus A square. Now according to, since it is a right angle triangle, according to Pythagoras theorem, O square is AB square, A square is BC square. Square of the two sides is equal to the sum of the square of the two sides is equal to the square of the hypotenuse. So I can write it as H square. I can write it as H square. Instead of O square plus A square, I can write it as H square. H square by H square, I can cancel it. I can write it as 1. So same way you can see the proof of these two also. So this is the basic 3 ratio or 3 trigonometric identities. We'll study some more identities. Before that, for all these 6 ratios, we can find the values of it. We can find the values of it, and there are some specific tables like sine of 90 minus theta. All those things we'll see now. First thing what we're going to see is after this. Now we all know we'll measure 1 degree, 2 degree, 3 degree, all those things, which actually we are taking it to be 1 degree. Take a circle, draw a circle in a xy axis, xy plane. Right. Now, if I just split the circle into 360 equal parts like this. Now it has been split into 4 parts, 4 equal parts, right? 8 equal parts. Like that, if I split into 360 equal parts, I'll get one area, one small part, small region like this, right? Yes, small region like this. So that angle we call it as 1 degree. After splitting the circle into 360 equal parts, 360 equal parts, we'll get a measure, small measure like this, right? So that measure we call it as, actually it is not, I have not split it into 360 equal parts. It is not possible to draw the diagram now. After splitting it into 360 equal parts, we get a small measure. That measure we call it as 1 degree. That measure we call it as 1 degree. So if we split into 4 equal parts, then what is this measure? What will be this measure? This measure is nothing but 90, and this measure we all know semicircle, it is 180 degree, and this measure is 270 degree. From here to here it is 90. From here to here it is 180. From here to here, this full angle we call it as 270 degree. and the full circle like this, we call it as 360 degree, right? So this is the special angle 98, 180, 180, 270, 360, right? Now this is the angle, this now we are getting the angle measure for a from a circle. We are able to see the angle measure from a circle. If I split into 360 equal parts, we'll get a small measure. We call it as 1 degree, right? Now we have 6 trigonometric ratios. How will we calculate the values for all the 6 trigonometric? Like if I want 45 degree, sine of 45 degree, how will we calculate? You know the table, right? We have a table for 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. This table you would have studied in 10th standard itself. What is the value for sine 0? What is the value for cos sine 0, sine 30, sine 45? For all the 6 ratios, for all the 6 trigonometric ratios, we all would have studied in your 10th standard itself. What are the values? Sine, cos, tan, secant, cosecant, cot. For all the 6 trigonometric ratios, we have studied this table. Now we have a new table that is will be calculating some different angles. For example, after till 90, okay, you know. For example, if I want to calculate sine of 120 degree, how will I calculate? How will I calculate cos of 240 degree? All those things we'll see now. To find the values for these tables, we need a table. Actually, it is a big table, but I'll tell you how to remember the table without memorizing it. How to remember it with a short method. That is, we have a formula for sine of minus theta, cos of minus theta, tan of 90 minus theta, cot of 270 plus theta. Yes, like that we have a big table for 0 minus sine of minus theta, cos of minus theta for all the 6 ratios. We have this minus theta concept, minus theta values, right? For all the 6 trigonometric ratios, we have this 90 minus theta, sine of 90 minus theta, cos of 90 minus theta, what tan of 90 minus theta. For all the 6, we have this 90 minus theta. For all the 6 ratios, we have what is 90 plus theta. For all the 6 ratios, we have what is 180 minus theta, what is 180 plus theta, what is 270 minus. So 0 minus 90 minus 90 plus 180 minus 180 plus 270 minus 270 plus 360 minus 360 plus. So for this we have 6. For this we have 6. So totally how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, 6 are 54 and values we have. We should know 54 values. So it is there in a big table in your textbook. You can check it. But instead of memorizing it, how to make it easy and understanding it with a short method, we'll see now. Out of these ratio, these angles that I wrote, 0 minus 90 minus 90 plus, let me write it 0 minus 90 plus 90 minus 90 plus 180 minus 180 plus 270 minus 270 plus 360 minus and 360 plus. In that, if you draw the diagram, this 0 minus is actually nothing, empty. Okay, so that is also stable. And 180 minus 180 plus. 180 means half, right? In chemistry, you would have studied that completely filled, half filled. Completely filled and half filled, we call it a stable configuration. And partially filled, we call it as unstable configuration. It will change. It will stay. Now, unstable means what? It will change, right? It will change its character like that, right? So 180 minus 180 plus it is like half, right? Whether it is minus or plus, 180 means half. So it is like half filled. 360 minus and 360 plus is what? It is like completely filled. It is like completely filled. Okay. And 0 minus it is empty. So we can consider that also to be some stable. We will take that also to be stable. So these 5 values, when I have these 5 things, it will never change. Sine will be sine itself, cos will be cos, cos will remain as cos itself. Then all the 6 ratios will remain as the same, right? But for the remaining 90 and 270, 90, these 4 things, 1, 2, 3, 4. These 4, it is like partially filled. So it is unstable. If you have not studied in chemistry so far, you will study in future, right? About this partially stable, filled, completely filled, all those things, right? So 90 and 270 is like 90 means what? Quarter, and 270 means 3/4. So compared to half and full is like stable. 90 and 270, quarter and 3/4 is not. It is not like a stable one, so unstable. So for these 4, it will change. If it changes, means it will change to what? Sine will change to cos, cos will change to sine. tan will change to cot, and cot will change to tan. Secant will change to cosecant, cosecant will change to secant. So please remember these 5 values. The circled values will not change. The circled values, the circled angles will not change. That I have taken some 4 angles. For those angles, and you get these 4 things, it will change. It will change means sine means it will change to cos, cos means it will change to sine, tan means it will change to cot, cot means it will change to tan, secant will change to cosecant, cosecant will change to secant. Right? Now, if I want to calculate any values, like for example, and regarding, but I don't, with the help of this and this, we cannot tell the exact answer. We must know whether it is positive or negative. For that, we must see this all silver teacups concept, all silver teacups. Right? All means all are positive in that quadrant. Silver means sine, silver S means sine and the reciprocal of sine, cosecant. Sine and cosecant are positive, remaining are negative. Tan and cot are positive, remaining is negative. Cos and secant are positive, the remaining are negative. So which is 90 minus, this is 90 degree, this is 90 degree. 90 minus means less than 90, so it will come to this side. Right? 90 plus means greater than 90. 91, 92 will come this side, 90 plus. 180 means this part. 180 minus means 179, 160. So it will be less than 180. 180 minus will be less than 180. So this side. 180 plus will go where? It will go here. Right? 180 plus greater than 180. 181, 182, 190. So this is 270, right? From here to here it is 270. Less than 270. 270 minus will come here. 270 plus means it will go there. 360 from here to here. Fully just 360. 360 means up to here. Yes? So 360 minus means lesser than this. So 360 minus will come here. 360 plus will go here. 0 minus means this is 0. 0 plus means this side. 0 minus means down. So 0 minus will come here. Right? So these 3, these 2, these 2 and these 2. Now you take the table. You can cross check. If you have the textbook, you can cross check. I'll do whatever I'll do. You can cross check it there. I'll do it directly without the table. If I want tan of 360 minus theta. Now, as I told you, 360 is stable, right? So it will not change. So it will remain as tan of 360 minus theta will remain as tan theta. It will not change the cot. It will be tan theta. Now, whether to know whether it is positive or negative, 360 minus is which quadrant? It is in this quadrant. It comes here. In 360 minus, which is positive? Cos is positive and secant is positive. But my question is what? My question is neither cos nor secant. So my answer will be negative. So what is the value for tan of 360 minus theta? It is minus tan theta. So you can check it there in the tabular column if you have it. Right. Let me put one more value. Secant of 270 plus theta. Now 270 plus means what will happen? 270 plus means 270 means it will change. That is plus or minus. 270 is unstable, so it will change. Secant will change to what? It will change to cosecant theta. Cosecant theta. Right? So secant plus 270 means it will change. Secant will change to what? Cosecant. Now whether it is plus or minus, 270 plus comes here. Don't see the answer. Right? See the question. Right? 270 plus means here which is positive. Cos and secant is positive. My question is what? Secant. So it is positive. So the answer is cosecant theta. If you want, you can check some other values. Let me put it here. Let me take like cos of 180 plus theta. What is cos of 180 plus theta? 180 plus means it will not change. 180 plus means it will not change. Right? So I'll write it as cos theta because 180 means it will not change. So cos theta as it is. Now regarding plus or minus, 180 plus means it comes here. So tan and cot are positive, remaining are minus. Question is neither tan nor cot. So minus. Yes. Likewise, if you want, you can tell me. We can do cosecant of 270. Cosecant of 270 minus theta. 270 means it will change. Cosecant will change to secant theta. Secant theta. 270 minus means which quadrant? 270 minus means this quadrant. Here tan and cot is positive. My question is neither tan nor cot. So minus. So as I told you, there are 54 values. 54 values. No need to memorize the table with the help of this diagram and this and this. But these data, these three things. If it changes, it changes to what? And for what it changes and for what it does not change. And with this diagram, all silver teacups, we can easily find the values for all the 54 value questions that we are that is given there in the table, right? Now some of you I didn't do the 0 minus, so let me do one for it. For example, if I want to find sine of 0 minus means what? 0 minus 1 minus 1, 0 minus 2 minus 2. So 0 minus theta, instead of writing I can simply write minus theta. Now 0 minus is stable, so it will not change, so it will become sine theta only. Now whether it is positive or negative, 0 minus means it comes here. Cos and secant is positive. My question is neither cos nor secant, so it will be minus. What about cos of minus theta? 0 minus is stable, so write cos theta as it is. Regarding for plus or minus, 0 minus comes in this quadrant, so here cos and secant is positive. Cos and secant is positive, so it is cos of minus theta is cos theta, right? So you can easily calculate the all the 54 values that we have with the help of these three concepts, right? So we have seen what is a trigonometric, what are 6 trigonometric ratios, and we saw the basic 3 identities, and we have many trigonometric identities that has to be discussed. Let me start with for all the trigonometric identities, there are some 12 trigonometric identities, which is the base. With the help of those 12 only, we will be developing. Remember all the formulas for cos 2 theta, cos 3 theta, sin 2 theta, tan 2 theta, all these formulas we will derive it from a set of 4 formulas. Actually, if you remember first one 4 set of formulas, that 4 form with the help of 4 formulas, we can derive around 20 formulas with the help of that 4 formulas. For that, but those 4 formulas you have to memorize. But there is a proof for that also. If time permits, we'll discuss that also in our next session. What is the proof of those 4 formulas? First, let me write those 4 formulas, which is the basic for all the trigonometric, almost all the trigonometric ratios. Sorry, almost all the trigonometric identities that we are going to see. Fine, because in trigonometry, most of the students they feel it difficult. The reason is it is difficult to understand and memorize the formulas. Even though they memorize it, in exam they get confused whether to, for example, sin 2 theta is or cos 2 theta is 2 cos square theta minus 1 or 1 minus 2 cos square theta. There is some small confusions like this. If you go through the proof now, what we are going to short derivation of the formulae, it will be easy. In case if you get confused also, you can cross check it, right? The 4 formulas which is basic for everything is, let me write it. Sin of a plus b equal to sin a cos b plus cos a sin b. Sin of a minus b equal to sin a cos b minus cos a sin b. Cos of a plus b equal to cos a cos b minus sin a sin b. Cos of a minus b equal to cos a cos b plus sin a sin b, right? Now these 4 formulas also we have the proof. If time permits, we'll have a separate session to we cannot do all the 4 proofs, and I'll do one proof if it is possible, right? But with the help of these 4 formulas, we can derive around 20 formulas, right? We are going to see that only now. If time whatever possible, we'll take for the first 8 formulas we'll see now. With the help of these 4 formulas, we'll derive 8 formulas now. The remaining formulas we'll see in our next video. First, we'll see with the help of these 4 how can we derive the first 8 formulas. If I add these two, what I'll be getting? Add these 2 equations. Let me take okay, add 1 and 2. 1 plus 2, what I'll be getting? Implies I'll be getting what? Left hand side, LHS plus LHS. Sin of a plus b plus sin of a minus b equal to what? If I add, what will happen? Cos a sin b, cos a sin b, plus minus will get cancelled. Same term with same sign, it will get added, and you will have 2 sin a cos b, 2 sin a cos b. If I add these 2, I'll get this formula. If I subtract this from this 1 minus 2, I'll be getting what? Sin of LHS minus LHS. Sin of a plus b minus sin of a minus b. So subtract means I will put minus here, minus, it will become plus. Now this will get cancelled, this will get added up, and you will have cos a sin b plus cos a sin b. You will have 2 cos a sin b, 2 cos a sin b. Now subtract, add these 2, what will get? 3 plus 4. 3 plus 4 You will be getting what? 3 plus 4, you will be getting cos of a plus b, cos of a plus b plus cos of a minus b equal to what you will be getting? Add these two. This will get sin a sin b, sin a sin b minus plus cancel. Same term will get added. You have 2 cos a cos b, 2 cos a cos b. Now if I subtract these two, but if I subtract these two, I have a minus in the front because the minus term here the plus for plus term, something plus something, something minus something. This was the minus term was in the second place, but here the minus term is in the first place. So instead of subtracting 3 minus 4, it will be better if I subtract 4 minus 3 to get the positive number in the front place, right? So 4 minus 3 means this minus this. So cos of a minus b minus cos of a plus b will be equal to, so put a minus over here, minus this minus this minus this plus. So this will get cancelled to cos a, sorry, this minus this will get cancelled, cos a cos b minus cos a cos b cancelled, sin a sin b plus sin a sin b will become 2 sin a sin b. Yes, now we will use this formula when it is given in product like sin 45 cos 35. What we with the help of this, if the sin and cos is given in product and we should express it as a sum or difference means, here sin into cos, here sin plus sin, sin minus sin, cos plus cos, cos minus cos. Right hand side everything is in product, sin into cos, cos into sin, cos into cos, sin into sin. So if any whenever sin and cos is given in product like sin 45 into cos 35, sin 30 into cos 60, something like that. If they're asking you to sin x into cos y like that, if they're asking you to convert that product into sum or difference, we will use this formula, but in the reverse way. In the place of this, the rest we will write this as our LHS and that is our RHS, right? Now from this formula we will derive another, with this 4 I derived this 4. Now with this 4 we will derive another set of 4 formulas. With that we will stop today and continue the next thing. After that we have still more formulas to be derived from these 8-12 formulas that we will discuss in the next video. Now, with the help of these 4, we will derive another set of 4 formulas. Let me take this to be 1, let me take this to be 2, let me take this to be 3, let me take this to be 4. Now, let me write, instead of a plus b, put theta and phi. Put a plus b equal to theta, a minus b equal to phi. Theta and phi are Greek alphabets. If it's confusing for you, you can take it as x and y also. It's up to you. So theta and phi. Now, if so, it will become sin theta plus sin phi equal to, if a plus b is this and a minus b is this, what is a and b? In the place of what? Here you will put theta, here you will put phi. Here a and b, what you will substitute? For that, solve these two equations. A plus b equal to theta, a minus b equal to phi means cancelled, a plus a, 2a equal to theta plus phi. So a equal to what? A equal to, bring this 2 here, theta plus phi by 2. So in the place of a, I will put theta plus phi by 2. Same way, a plus b equal to theta, a minus b equal to phi. Now here I have added these two. Now subtract these two, what will you get? Minus, this will become plus, this will become minus. So a minus a cancelled, 2b equal to theta minus phi. So b equal to theta minus phi by 2. Now, in the place of a plus b, what I am going to substitute? 1 implies. In the place of 1, let me write sine of, this is nothing but theta, this is nothing but phi. So sine, this formula will become, if I use this, sine theta plus sine phi equal to 2 sine, in the place of a, substitute this. In the place of b, substitute. So theta plus phi by 2 into cos of theta minus phi by 2. Right? Yes. So first formula is over. So let me rub it. Now the same thing. Now use the same thing in the second form equation. What will be getting? Sine of a plus b. So sine of theta minus sine of phi equal to 2 cos a. A is nothing but what? A is nothing but theta plus phi by 2. Theta plus phi by 2 cos of theta minus phi by 2. Theta minus phi by 2. Now, right. So the second formula is over now. Sorry, 2 cos into sine. Sorry, sine 2 cos theta plus phi by 2 sine of theta minus phi by 2. So let me rub the second equation now. So third equation, with the help of third equation, cos of theta a plus b is nothing but theta plus cos phi equal to 2 cos of theta plus phi by 2. 2 cos theta plus phi by 2 cos of theta minus phi by 2. Right. So this formula, third equation over. Let me come to the fourth formula now. So 4 implies what I'll be getting, cos of, now listen, don't do mistake, a minus b is what, 5. So this alone will be cos phi minus cos theta equal to 2 sine of theta plus phi by 2 sine of theta minus phi by 2. Right. Now we have studied 12 formulas. For the help of first 4 formulas, I have derived 8 formulas. This 4 and the previous 4. Right. So with the help of the first formula, let me, for a sample here, we still have many more formulas to derive it. But all these derivations is just for just to check it. If in case you have any confusions, you can just check it out. But you should memorize the formula, so that in the exam you cannot derive all this formula and keep it in a paper. But if it is possible, you can do that also. You can, before the exam, in the initial 10 minutes, if it is really difficult for you to memorize, you can do all these things. It will take around 15 minutes or 15 minutes maximum to derive all the trigonometric formulas in a paper, and you keep it, and then you can start your exam. Now we have still more formulas to derive. I'll just start with one formula alone. For example, what is sine of a plus b? Sine of a plus b is sine a cos b plus cos a sine b. This is the first formula that we saw today. Sine a cos b plus cos a sine b. Now put a also equal to theta, b also equal to theta. What you will be getting? Sine of theta plus theta equal to sine of theta plus theta equal to. Now we will see sine of theta plus theta equal to sine theta cos theta plus cos theta sine theta. Right. So sine theta cos theta, listen. A, in the place of a also I am putting theta, b also I am putting theta. So theta plus theta, sine theta cos theta sine theta. Now actually it is the same. Sine theta cos theta, sine theta cos theta is nothing but 2 sine theta cos theta. Theta plus theta is nothing but 2 theta, right? So formula for sine 2 theta is nothing but 2 sine theta cos theta. So how we are getting the formula for sine 2 theta to be 2 sine theta cos theta? With the help of, in the place of sine, in the sine a plus b formula, sine of a plus b formula, in the place of a also you put theta, b also if you put theta, for sine 2 theta you will get 2 sine theta cos theta. I hope you understood this session. From this we have still more formulas that can be derived with the help of the formulas that we know. That is the first 4 formulas. We'll discuss in the next session. Thank you.